I had some issues. Jet lag. Jet lag. See, in US right now it's night. Here it's day. But once you travel from the US to India, have you noticed it? When you look at the globe, US where I live, and India where what the Jarenda is located, is really opposite side. Right opposite side of it. But one thing, when I look at it, it's really quite interesting. Why? The route that I come to Jalenda, US to Europe, Paris, and then come back to Jalenda. I don't know why they are not looking at the other side of it, which means US to Asian country, and then Jalenda. It's same. Well, distance-wise, it's the same. However, there is not that type of route. So if that is the available, then probably I will take that one. Okay, today, this is really not a short kind of lecture, because evaluation and selection of liquid filtration system based on application. However, I have only small area of expertise, not all of the expertise. There is no way you can do it. So we're going to cover all of the area available in the liquid filtration area. First part of it. Second part, that is quite interesting, I believe, interesting to you. Have you heard of MBR, process for wastewater treatment? Have you heard of it? Membrane bioreactor. So we're going to go over something. So also there is the recent another technologies. So we're going to go over recent technologies that is applying in the wastewater treatment. So I don't think anyone currently covered the MBR or some of the newest technology. That's why I told you yesterday, you're lucky because you're going to learn newest technology available. Then how you want to select liquid filtration system? This is the filtration system. So the first, somehow you have to define application requirement, types of water or liquid, whether it's water or chemicals or food, beverage, pharmaceutical. The water, potable, wastewater, seawater. See, this afternoon we're gonna have some hands-on experiment a little bit. We can use the some lube oil or some other things. However, we don't have enough time, so we're gonna use water. A simple water with some sand into it. So probably later on, once we set it up, the experimental setup, then we make some groups, and probably in the afternoon sometime, you can do one group use the constant the pressure experiment, a variable pressure experiment, something like this. Then you could understand the equation that I gave you yesterday a lot better. But yesterday I just skimmed through it, but because if you don't do the experiment, it's hard to understand. Even though you understand, you forget really quickly too. So the purpose of filtration, what is the contaminant? What is the important solid material that we like to have it? And then product recovery, equipment and protection. Second one is the analyze the fluid characteristic. The viscosity is really important one. The temperature, pH level is good. Professor Mukwate already covered the particle size. Distribution is important. And so loading itself is important one. And then third one, determine filtration requirement. Certainly this is efficiency related. And flow rate is important. The operating pressure, well, pressure and flow rate, that's critically important. They compare with air, the liquid, the pressure is really important parameter. Just like the previous lecture, is that the continuous or batch? Then how we can clean the system itself? That's the important part of it. And number 4, select the filter type. What type of? By configuration, bag filter, or cartridge, or self-cleaning, or membrane filter, micro or ultra cellular depth filter, and then mechanism, that's surface filtration, depth filtration. Now, fifth, material comparability. This is quite important. Comparability. The solution that you want to use, hey here, when I work for the Cummins engine company, the lube oil, we try to develop the lube oil filter media. Also the gasoline, fuel filter, the hydraulic filter. Then somehow you have to look at the comparability. Whether it's dissolved a little bit, then you have trouble. The cooling water is trouble. Cooling water is actually alcohol content is really high. So the alcohol dissolves some of the materials, organic materials. So it's comparability is quite important factor. And then what type of housing? The SS operation and economic factor. So economic factor comes normally first. Whether this one is expensive to make it or not. So certainly the maintenance issue, change out, disposal. Now disposal is big issue. Luckily, US, we are still dumping away land something only. But because land is huge, but in India, I doubt it. I know, so disposal is a big issue. So later on, but he already mentioned about the PDF, not PDF, PVDF, the membrane. That considered to be not really good material, but however, I doubt it. So they call it PFAR. Have you heard of PFAR? I'm going to talk about that one later. Yeah, TCO, this is big issue. Total cost of ownership. This is a big issue currently. Along with the greenhouse, that's actually related to TCO. We're going to talk about that one a little bit later at the sustainable filter media development. And then this one is important factor, the regulatory and safety consideration. Whether it's food grade, pharmaceutical grade, environmental regulation. Currently, there are so many regulations on water and everything. So, one is vendor and technical support. So, this is all necessary item to look at it. Here, evaluating leakage filtration by application. Back filter is the cost issue is really low. What about cartridge filter? It's moderate. Sand filter, quite low. This afternoon, tutorial 2, I'm going to start with sand filter, the example of sand filter. I think when I don't know whether you have the copy of ebook. Do you have it? Not yet. Not yet. So it starts with the sand filter, Fujimon. Have you? I don't know. Any person who actually visit Fuji Mountain in Japan? See, I traveled to India several times because I have the project with them. That's really close to the Fuji Mountain. The Fuji Mountain, around that area, there are a bunch of the so-called clean water. Actually, it's really clean water because the Fuji Mountain, top of mountain, you can see the snow there and rain. Normally, they pass through the sand for 100 years, something like this. So around that area, there are several villages. They do use that water, really clean water, also tastes really good too. So basic technology, sand filter, sand filter. But nowadays, there are actually some places you have to pay to get it in. But the water taste is really great. If you like to visit the Japan, go to Fuji Mountain and taste their water. How delicious the water is. And then sand filter. Sand filter is the original filter material, but still using it though. And the membrane filter and centrifugal separator. However, membrane, the bad part of membrane is cost. Cost is quite high. There is one lecture about the membrane. I'm actually looking at the manufacturing side of it, how we can produce the membranes. There are several different type of membranes, so that we want to go over manufacturing, how they can manufacture something like that. Centrifugal and pressure lift. Vacuum belt. So application area, the industrial water and pharmaceutical, you can look at it, something like that. This chart is quite handy. So if you like to design something, so I don't want to go over every bit of it, but once you have this slide, also if you have a project or something, then you can look it up and get the right answer. This one is a little bit different from the other side of it. This one has the operational cost, scalability, flow rate, and filtration rating as well. Cartridge filter, bag filter, I'm going to skip. Sand filter, cartridge filter, bag filter, disc filter, membrane filter, and efficiency. Certainly, the sand filter 20 to 50 micrometer, and cartridge filter 1 to 10, bag filter 5, membrane 0.1 to 0.1 micrometer. And the cost issue and operating cost and the footprint, maintenance, and backwash requirement, replacement. Pre-filtration, and final one. I'm going to skip two. Selection liquid filtration system for chemical plant application. The efficiency is important one, solid handling and flow rate. See, chemical compatibility is quite important. The here footprint, the carbon footprint is quite kind of buzzword right now. Do you know what the carbon footprint is? Carbon footprint is. What is that?
Carbon dioxide that is being emitted.
Huh?
It's the amount of carbon dioxide that is being emitted in each activity, let's say.
Yeah.
And it's expressed in tonnage.
Yes, carbon footprint, that is currently the buzzwords right now. The disposable is a big issue. So also well, I'm going to talk about something like this: the sustainable filter media development. But surprisingly, the carbon footprint, something like that, is quite big issue in Europe and Asia. However, in US, we are not actually paying much attention to the carbon footprint in US. But Europe is a big issue. Yeah. Also, the Asian region is the same thing. But since I'm living in US, we really don't care much.
Can I ask you why?
Huh?
Why you don't care about carbon footprint?
Every area, I'm going to talk a little bit about it. Every area, in US, certainly, I'm involved in the standard development. I'm quite active on the ISO TC 142. I'm the convener of two work groups currently. Also, I am involved in the ASHRAE. You know what the ASHRAE is? Yeah. American Society of HVAC and refrigeration. So it's huge. The member is we have the two conferences every year. Probably the member comes from the ASHRAE conference, about 5,000 people. So it's huge. So ASHRAE has a standard. The ISO has a standard. However, ASHRAE using different units. They are not using CGS unit, different unit. They don't want to change it. The other thing, ASHRAE has money to develop the certain things. If we like to have the standard, then this is trouble. We have to solve it. Then somehow we need research to solve it. So every time we try to establish the test standard, they create research project, and then someone has to write the RTAR, which is research proposal, and work statement, which is the go to the bid. So some university job one bidding, and then we have to choose one research institute so that they can get the project, and normally it takes 3 or 4 years. So once they finish the project and then get the result, we use that result for making standard. That's the 52.2 in every part of the standard came out of based on the research project. But what about ISO? ISO doesn't have money. Well, I don't know whether I can say it, but I'm quite involving in ISO. That's why I can tell you. ISO standard is following ASHRAE standard, modifying a little bit. And most of them are like that. That's why US is not much pay attention to some of the other world. Yeah? So,
US consumption for energy is much higher.
yeah.
So why they project that there is a problem? Issue is that US, even if you see the inside the room, they are using air conditioning always. Outside climate is quite good. But in India that will never happen. Outside climate is good. No one will be using the AC. Air conditioner. My son is living in US. He is inside the room and running continuously, AC is running. But outside climate is quite good. But that will not happen in India where energy cost is very high. So they don't want to show that our energy cost. Because more the energy consumption, greater will be the problem with the carbon footprint.
Well,
Yes, that is the so that is the weak point. They don't want to show their weak point.
And they are consumers, not
They are the major consumption for energy. Major consumption for energy.
well, yeah.
But India is also there is a problem. India there is a lot of problem, particularly environmental part. India is lacking far behind. China improved a lot. With the time, China improved a lot. Initially, China was at the top, but then now China improved a lot, and India is behind. Because if you see environmental part, water pollution, air pollution.
So that is actually a big part of the evaluation and selection of the liquid filtration system. You have to follow the government regulation first. In US, we don't have a lot of restriction, but India is different. So, so last time when I was here, I actually talked about the PTFE, ePTFE membrane. But one professor asked me, "Hey, ePTF is one of the P5, which means so-called they call it everlasting material. There is no way you can degrade. It's not degrading, staying forever. Also, it has some the bad material coming out. It can harm the human body, something like that. But actually, I never heard of something like that in US. But not there. When I was speaking some PTFA, one professor asked me, "This is bad material in the future." I didn't understand that. But still, if you don't have PTFA or ePTFA, then you got a big trouble in medical field, some other field. So certainly I'm gonna go over some that topic in the sustainable material development. Since I'm living in US and coming to the Jarenda, so some portion I really don't understand, but that's reality. I have to go by the reality. So. Liquid filtration separation food processing is slightly different from the chemical plant applications, but not really a lot different. Certainly, he already covered all of those. So the membrane filtration, I have the one course, one lecture. Is that tomorrow or some? It's pharmaceutical. So it's almost the same, but slightly different for the application wise. Now we're gonna go main topics. The interesting area is DAF, MBR, and ASP. The dissolved air flotation, that topic I already covered yesterday. But membrane bioreactor, I have several slides talk about this one so that you can get some outline of what's going on. And the other one is the activate sludge processing, ASP. Is new area as well. So those three areas is current technology to treat the waste water treatment. So I'm going to give you some outline for that. Well, you already covered that one. Flocculation, that's the what I cover next. This one already he covered. DAF. Well, we already covered that one yesterday. Frost related. A mineral. The same thing, but the dissolved air flotation systems. So waste water coming out, coming in, and then somehow we have to introduce some air into it, make bubble, and then you eliminate suspended waste. DAF is the description of DAF itself. They remove total suspended solid, TSS. The TSS is quite important terminology. Total suspended solid, biochemical oxygen demand, BOD is another one, oil and gases, waste. The contaminants are removed using dissolved air in water solution produced by the injecting air. You saw the picture, previous picture. Injecting air under pressure into a recycled stream of classified DAF. The feed water to the DAF float tank open, not always. Those with coagulant such as ferric chloride, aluminum sulfate. This is quite the common material for coagulant. We're going to go over a little bit in the afternoon session. He already showed you the picture in the water using coagulant. The portion of the classified effluent water living in the DAF tank is pumped into the small pressure vessel called air drum, into which compressed air is also introduced. The saturating, pressurizing effluent water with air. Saturated water stream is required. Is there anyone you're actually using DAF system? Anyone? Currently? Bubble form at the nucleation site. See, the terminology of nucleating is crystallization, and nucleating. Nucleating has to come first, and then crystallization occurs. So nucleation is quite important. You have to make the nucleation. What is nucleating? Here you have solution. You're going to introduce some nucleating, boom, one drop of it. Then what happens? Somehow it creates some solid material from the liquid. That's why we call it nucleating. And then crystallization occurs. Then you can form the crystals. That crystal contains some certain ingredient in the solution. So you can separate out them. So the nucleation is quite important terminology. So then what happened to, okay, this is the DAF actual system, the schematic actual system. The bottom one, they are using membrane in the final stage. And then upper one, they use the sand filter. That's a little bit different. They activate sludge process, top, external seismic, membrane bioreactor bottom. So the bottom one, they use bioreactor. So we're going to go over that one in detail. This is simple, the schematics, how the bioreactor works. So the waste treatment, you have to have some, you have to kill some germs inside water. Then how we can do it? So somehow you have to introduce gas molecules. Also, once you use gas molecule, then you have gas has to go out. Then somehow there is reaction to make NO2 from N. So anything, the water, something you can exhaust out of it. You know, you have to kill the germ first. And then somehow the rest of the material you use, we have to recirculate. So that is the right here, dissolved material. The easy way to say you have to have some sort of grab or kill or deactivate the microorganisms. And then use membrane, and then you can get the clean water out of the wastewater. Here, this is kind of a little bit long slide. It actually created 1969 in US. It started a long time ago. So bioreactor itself, yes. Because we, at that time, when right now is the same thing, the cost, energy cost is higher. The other issue is the membrane fouling associated with. So there are a bunch of research in Japan, 1970s, 1980s. Also, commercial development started 2000s. So it's kind of the recent technology. However, currently, most of the wastewater treatment plant, they do use MBR. Huh?
Why is that? Most of the water treatment plant, why is that?
You have to ask when I finish this slide. Yeah, I have several of them. So. There is some the YouTube. You have to write down there. YouTube. I don't use any YouTube at all. In US, the YouTube is not allowed. You can use personally, but officially it's not. Officially not allowed. Yeah, not allowed. Yeah, that's my habit. So once it's I'm following some US rule. So probably here you can use YouTube, but I want you to write down this one. You have that one anyway. So look at it. It's kind of a little bit long, the YouTube, the video. Yeah, maybe about 15 minutes, something like that.
About the history.
Yeah. Your link is the source is right down there. Yeah. Right here. So the copy, make a copy, and then put it in the website, then you'll see. Yeah. The membrane bioreactor have emerged in wastewater treatment technology for choice of active sludge process, ASP. They replaced the ASP with the NBR. One of the most important innovation in the wastewater treatment. That is true. So the microfiltration and ultrafiltration membrane technology with the pore size ranging from 0.05 to 0.04 micrometer. So currently widely used in municipal industrial wastewater treatment. I believe the India, they do use some here. I believe, I strongly believe. Because in India, you need this. The less area requirement, excellent fluence quality compared with ASP. This is always problem. Membrane, this is always problem, fouling. But certainly it's high cost issue. Here, he already covered this one, but this is a little bit different one. So, microfiltration, ultrafiltration, small colloid viruses, bacteria, of course, you can remove it. And nanofiltration, dissolved organic matter, divalent ions, and ion specific, reverse osmosis. This is the schematics. We're going to go over anodic biozone and aerobic biozone, both of them in detail. So pre-screening, you normally use the wire mesh, and biological treatment, membrane separation, and then you can get the clean effluent. So then what is the anionic biozone or aerobic biozone? It looks like this. I don't know whether there is detail of it. Detail, yeah, right here. It happened during the anionic sick biogen environment, low oxygen, but nitrate NO3 is present. Main process is nitrification, microorganism, facultative anaerobic bacteria function, NO3 into N2. This happens after so this is actually removing ammonia. And then what about aerobic biogen? Main process carbon oxidation, nitrification, and sometimes phosphorus removal. The function of breakdown organic matter. This is quite important. All the organic matters breakdown, which means the killed organic matter deactivate ammonia in biological phosphorus. Some phosphorus removal you can remove it. So here the switch comes in and primary classifier, then you go through the bioreactor. And then MBR tank, that's what we are seeing. It's going backward. Yeah, right there. You see the aerobic stage, MBR module is back there. So the anionic biogen use aeration, oxygen absent, and use the denitrification, nitrite and nitrogen gas, which will return activated sludge into recycled from aerobic tank to interest nitrogen. So the final state is membrane union, physically separating treated water from biomass. It's details, wastewater. I believe you already seen this one, the screening. It's really common for the wastewater treatment. And then I don't know how to spell it, how to pronounce it, ANOXIC. Huh? Anoxic. Anoxic condition involve the environmental free oxygen. And anoxic John is wastewater useful for nitrogen removal and bacteria breakdown. The purpose is this one, kill the bacteria and deactivate bacteria. Allow the conversion of NO3 to N2 so that you can get it out of the system itself. Next step is aerobic tank, nitrification, actually nitrification. to create aerobic condition by diffusing air. So certainly we already covered that one. So nitrification takes place. Ammonium is converted to NO3. Wastewater, there are a bunch of ammonia there, so you need to get rid of that. And membrane filtration. So there is some cartoon back on the right hand side, and the X-ray sludge and the water bubbles. This is the membrane. So more common in industrial setting, and the other is more common in municipal water setting. In municipal water, a slightly different MBR system, and then the industrial setting. Yeah, membrane module right there. Here, membrane module is inside. That's the difference. Application, water, wastewater. Probably this is a big area, wastewater. There are three types of membrane. The hollow fiber, he already covered that one, flat sheet, and then tubular. Membrane, there are three types. I don't know whether you can see the difference. You have to look at the picture. This one, probably the Professor McLeod, he showed this one. So, in fact, they do use a lot of ceramic material, like this, hollow fiber, flash tube. How you want to clean? So clogging is always the issue. So physical cleaning conducted by back flushing membrane. This is a really common method using back flushing. Relaxed period, permeate withdrawal is stopped so that the skull can wash right off. And then chemical cleaning. I believe he already covered that one too. He covered. And this is some removal efficiency. So suspended solid, effluents, and BOD, and phosphorus, total nitrogen. What is the advantage? Less area required, less retention time, can meet the strict discharge limit, lower sludge protection, reduce elimination disinfection. Disadvantage certainly is a high capital cost. So most important thing is operating. See, operator is quite, he has to know, she has to know how it works. So, operator is quite important part of it. Complexity of process mainly due to membrane maintenance and cleanness. This is a bit different area. Activated sludge process. ASP process. So once you got your material use the salts, then there is video coming out. So it will help you to understand a lot better. So everywhere I put the salts there, so you have to look at it that way. So I did not know that in India we can use the YouTube video. If I knew before, I can put it in. But in US we cannot use it. This process is used for treating a sewage where microorganisms degrade an organic material, decompose organic material to separate in future classifier. So the important issue is how we can deactivate the virus and bacteria. And that's quite important issue. This is the activate sludge process. So sewage and screening and grit removal, you already knew, a primary classifier. And then some portion, which is the drainage, it comes down here and filtrate, aeration tank and sludge, and then sludge dewatering film down here. The upper effluent and aeration tank and secondary classifier, disinfection, and you can get the treated water. Typical characteristic of domestic sewage. This is not India, this is for US data. Important, this one is the kind of summary of the previous slides. Wastewater treatment to access quality treatability, wastewater BOD. BOD is biochemical oxygen demand. And then COD, chemical oxygen demand. And TSS, we already covered that, total suspended solid. TDS, total dissolved solid. Here, another one, TKN. I'm not sure what that is. I have to look it up, but I forgot to look it up that one. Total amount of organic, inorganic nitrogen compound in the wastewater. Biochemical oxygen demand, 5 days. And then chemical oxygen demand, total suspended solid. You can look at it. Oh, I think that's the final slide that I have. But the important thing is the MBR, membrane bioreactor. That's quite important message that I like to give you. What time?
Sir, timing is 12.
Huh?
Timing is 12.
I'm not really sure.
So, sir, you take just a 5-minute break so that.
Yeah.
So, everyone, this lecture is over right now. So,